Hello and welcome to this video. My name is Mumshad Mannambeth, and in this video, I will walk you through the Kubernetes API. We will first understand the different API groups and how, as an external user, you can get access to the Kubernetes API. We then look at the different API groups and versions. We will look at the API deprecation policy. We will see how the different APIs evolve and move through different phases of the API lifecycle over a period of time. And finally, we will go through a demo of our hands-on labs where we explore the Kubernetes API. Before we begin, don't forget to subscribe to our channel as we post new videos every week. Before we head into authorization, it is necessary to understand about API groups in Kubernetes. But first, what is the Kubernetes API? We learned about the Kube API server. Whatever operations we have done so far with the cluster, we've been interacting with the API server one way or the other, either through the Cubecontrol utility or directly via REST. Say we want to check the version. We can access the API server at the master node's address, followed by the port, which is 6443 by default, and the API version. It returns the version. Similarly, to get the list of pods, you would access the URL api/v1/pods. Our focus in this lecture is about these API paths, the version, and the API. The Kubernetes API is grouped into multiple such groups based on their purpose, such as one for APIs, one for health, one for metrics and logs, etc. The version API is for viewing the version of the cluster as we just saw. The metrics and health API are used to monitor the health of the cluster. The logs are used for integrating with third-party logging applications. In this video, we will focus on the APIs responsible for the cluster functionality. These APIs are categorized into two: the core group and the named group. The core group is where all core functionality exists, such as namespaces, pods, replication controllers, events, endpoints, nodes, bindings, persistent volume claims, config maps, secrets, services, etc. The named group APIs are more organized, and going forward, all the newer features are going to be made available through these named groups. It has groups under it for apps, extensions, networking, storage, authentication, authorization, etc. Shown here are just a few. Within apps, you have deployments, replica sets, stateful sets. Within networking, you have network policies. Certificates have the certificate signing requests that we talked about earlier in this section. So the ones at the top are API groups, and the ones at the bottom are resources in those groups. Each resource in this has a set of actions associated with them, things that you can do with these resources, such as list the deployments, get information about one of these deployments, create a deployment, delete a deployment, update a deployment, watch a deployment, etc. These are known as verbs. The Kubernetes API reference page can tell you what the API group is for each object. Select an object, and the first section in the documentation page shows its group details. v1 core is just v1. You can also view these on your Kubernetes cluster. Access your Kube API server at port 6443 without any path, and it will list you the available API groups. And then within the named API groups, it returns all the supported resource groups. A quick note on accessing the cluster API like that. If you were to access the API directly through curl as shown here, then you will not be allowed access except for certain APIs like version, as you have not specified any authentication mechanisms. So you have to authenticate to the API using your certificate files by passing them in the command line like this. An alternate option is to start a Cubecontrol proxy client. The Cubecontrol proxy command launches a proxy service locally on port 8001 and uses credentials and certificates from your kubeconfig file to access the cluster. That way, you don't have to specify those in the curl command. Now you can access the Kubecontrol proxy service at port 8001, and the proxy will use the credentials from kubeconfig file to forward your request to the Kube API server. This will list all available APIs at root. So here are two terms that kind of sound the same, the kube proxy and Kubecontrol proxy. Well, they're not the same. We discussed about kube proxy earlier in this course. It is used to enable connectivity between pods and services across different nodes in the cluster. We discuss about kube proxy in much more detail later in this course, whereas Kubecontrol proxy is an HTTP proxy service created by Cubecontrol utility to access the Kube API server. So what to take away from this? All resources in Kubernetes are grouped into different API groups. At the top level, you have Core API group and Named API group. Under the Named API group, you have one for each section. Under these API groups, you have the different resources, and each resource has a set of associated actions known as verbs.
We will now discuss about API versions. We talked about APIs and API groups, resources, and verbs. Now we're going to talk about API versions. We know that everything under APIs are the API groups such as apps, extensions, networking, etc. And each API group has different versions. Now what we see here is the V1 version. When an API group is at V1, that means it is a GA stable version, generally available stable version. The API group may have other versions such as beta or alpha as V1 beta 1 or V1 alpha 1 respectively. So what are these different versions? What do each of these versions mean? Now, alpha is when an API is first developed and merged to the Kubernetes codebase and becomes part of the Kubernetes release for the very first time. At this stage, the API version has alpha in its name, indicating that it is an alpha release. For example, it could be V1 alpha 1 or V1 alpha 2, etc. This API group is not enabled by default. For example, at the time of this recording, the API group internal.apiserver.ks.io, which has the resource storage version, is only available as V1 alpha 1. This means that if you were to create this object now, you will have to say in the YAML definition file the API version as internal.apiserver.ks.io/v1 alpha 1. However, this alpha version is not enabled by default. So if you try to create this object, you will not be able to do that. We'll discuss about how to enable a particular API version, specifically those in the alpha version, a few minutes later in this video. Now, since this is an alpha version, it may lack end-to-end tests and may have bugs. As such, it is not very reliable. Also, there is no guarantee that this API will be available in the future releases. It may be dropped without any notice in future releases. As such, this is only really for expert users who are interested in testing and giving early feedback for the API group. As of this recording, the API groups in alpha phase are the internal.apiserver.ks.io group. Now, after some time in the alpha version, and once all the major bugs are fixed and it has end-to-end tests, it moves to the beta stage. This is where the API version name gets beta in name, for example, V1 beta 1 or V1 beta 2, etc. The API groups in beta stage are enabled by default, and they have end-to-end tests. But since it is not GA, it may still have minor bugs. However, there is commitment from the project that it may be moved to GA in the future. So this is for users who are interested in beta testing and providing feedback for the features. As of now, the flow control group is in beta phase, as you can see from this chart. Now, after being in the beta stage for a few months and with a few releases, the API group moves to the GA or stable version. Now this is when the version number no longer has alpha or beta in it. Instead, it is just v1. And it is of course enabled by default in the API group, and it is part of conformance tests and has all the tests written. Now, since most bugs are fixed in alpha and beta stages in the API group, this API group is highly reliable, and it will be supported and present in many future releases to come. And of course, this is when it is available to all users. Now, as you might have noticed, most of the API groups such as apps, authentication, authorization, certificates, coordination, etc. are GA and stable now. However, if you look at some of them, they have multiple versions. For example, auto scaling has v1, v2 beta 2, v2 beta 1, etc. The Node API group has v1, v1 beta 1, and v1 alpha versions. And so why is that, and what does that mean? So an API group can support multiple versions at the same time. For example, the apps group can have v1, v1 beta 1, and the v1 alpha 1 all at the same time. This would mean that you will be able to create the same object using any of these versions in your YAML file. So say I want to create an nginx.yaml, I could create it with the API version set to v1 alpha 1 or v1 beta 1 or v1. So any of these will work. But even though there are multiple versions supported at the same time, only one can be the preferred or storage version. So what is a preferred version? Now, when you have multiple versions enabled and you run the Cubecontrol get deployment command, which version is the command going to query? That's defined by the preferred version. In this case, if v1 is set to the preferred version, then that is the command that it will query. Or when you run the Cubecontrol explain command, the version that it returns is the preferred API version. Also, when multiple versions are present, only one version can be the storage version. This means if any object is created with the API version set to anything other than the storage version, such as v1 alpha 1 or v1 beta 1, then those will be converted to the storage version, which is v1, before storing them into the etcd database. So that's what the preferred and storage versions mean. Preferred is the default version used when you retrieve information through the API using a Cubecontrol get command or something like that. And the storage version is the version in which an object is stored in etcd, irrespective of the version you have used in the YAML file while creating the object. So remember, only one can be the preferred or storage version. And even though the preferred and storage versions are usually the same, they can be different. They don't necessarily have to be the same. So how do you identify the preferred version if there are multiple APIs? So the preferred version is listed when you list that specific API. For example, when I list the APIs available for the batch API group by going to the URL as shown here, I see that it has v1 and v1 beta 1 versions available, which are the supported API versions, of which the preferred version is v1 as is shown below. And as of now, it is not possible to see which is the storage version of a particular API through an API or a command. So one way to find that out is by looking at the stored object in etcd itself by querying the etcd database directly. Here's a sample command where we are querying the blue deployment object using the etcd Cuddle utility using the get command, and in the output we see the API version to be apps/v1. So to enable or disable a specific version, you must add it to the runtime config parameter of the Kube API server service. For example, we talked about a number of alpha APIs earlier, and since these APIs are not enabled by default, you will not be able to create objects for them. So if you'd like to try those out, what you could do is you could actually add those to the runtime config parameter, and the APIs here are comma separated, you would like to enable, and specify the APIs that you would like to enable. And of course, once you do that, you must remember to always restart the API server service, and that goes to whenever you edit these options. And once done, you should be able to use that API and test it out. We will now discuss about API deprecations. So we discussed that a single API group can support multiple versions at a time. But why do you need to support multiple versions, and how many should you support? When can you remove an older version that is no longer required? This is answered by the API deprecation policy. While looking at the answers to these questions, we will also understand the rules in the API deprecation policy. First, let's look at the why. Let me give you a quick tour of the lifecycle of an API group. Let's, for example, say that we are planning to contribute to the Kubernetes project, so we create an API group called KodeKloud.com, under which we have two resources called course and webinar. This is just an example. So we develop it in-house and we test it, and when we are ready to merge it to the Kubernetes project, we raise a PR and hopefully it gets accepted, and we release it as an alpha version. So we call it V1 Alpha 1 because it's the first alpha version of the V1 version. You can create a course or a webinar object using a YAML file like this, and using the API version kodekloud.com/V1 Alpha 1. Now, let's say, for instance, the webinar object didn't go well with the users and we decided to remove it. In the next Kubernetes release, can we just remove it from the V1 Alpha 1 version? No. That's where the first rule of API deprecation policy comes into play. API elements may only be removed by incrementing the version of the API group. Meaning, you can only remove the webinar element from the V1 Alpha 2 version of the API group. It will continue to be present in the V1 Alpha 1 version of the element. So at this point, the resource in database is still at V1 Alpha 1, but our API version has now changed to V1 Alpha 2. So this is now going to be a problem. We will need to go back and change all API versions in our YAML files from V1 Alpha 1 to V1 Alpha 2, which is why the new release must support both V1 Alpha 1 and V1 Alpha 2. But the preferred or storage version could be V1 Alpha 2. This means that the users can use the same YAML files to create the resources, but internally it would be converted and stored as V1 Alpha 2. So that brings us to the second rule of API deprecation policy. API objects must be able to round trip between API versions in a given release without information loss, with the exception of whole REST resources that do not exist in some versions. If we create an API, an object in the V1 Alpha 1 version, and it is converted to V1 Alpha 2 and then back to V1 Alpha 1, it should be the same as the original V1 Alpha 1 version. For example, we have a course object in V1 Alpha 1. It has a spec field called type set to video. This is then converted to V1 Alpha 2. With V1 Alpha 2, we introduced a new field called duration. This field was not there in V1 Alpha 1. When we now convert this back to V1 Alpha 1, it will now have the new field, but the original one didn't. So we must add an equivalent field in V1 Alpha 1 version so that the converted V1 Alpha 1 matches the original V1 Alpha 1 version. So continuing with our story, we fixed some more bugs and are now ready for beta. Our first beta version called V1 Beta 1 is now ready, and then after a few months we release the next beta version, V1 Beta 2, and finally we release our stable version, the GA version, which we call as V1. So that's kind of how an API evolves over time. Starts with V1 Alpha 1, then Alpha 2, and if required more alpha versions, and then to beta versions, Beta 1, Beta 2, and more beta versions if required, and finally V1. Now, we don't have to have all the versions available at all times like this. Of course, we must deprecate and remove older versions as we release newer versions. So let's look at what are the rules and best practices around that. So let's say with the Kubernetes release of version X, we released the v1 alpha 1 version of our API group. So X here could be Kubernetes version release 12.1.1, for example, and that's the first time our package was included. So we made it version v1 alpha 1. Now, since it is the only version, it is the preferred and storage version. With the Kubernetes release of X+1, we released the v1 alpha 2 version of our API group. Now, since we are in the alpha phase, we are not required to keep the older v1 alpha 1 version as part of this new release. And this is part of the rule 4a of the Kubernetes deprecation policy. This rule states that other than the most recent API versions in each track, older API versions must be supported after their announced deprecation for a duration of no less than GA 12 months or 3 releases for GA, and 9 months or 3 releases for beta, and 0 releases for alpha. So alpha versions need not be supported for any release, but beta and GA versions, once released, must be supported anywhere from 9 to 12 months. So that's why the release X+1 does not have v1 alpha 1. So that may break things for those who had previously used the v1 alpha 1, as we discussed earlier in this video. And so you must mention about this change in the release notes of that Kubernetes version. Here's an example of one such mention of the removal of v1 alpha 2 config API, and the release note requests users to convert the v1 alpha 2 to v1 alpha 3 in that example. We will talk about how to do just that a bit later in this video. So now in the X+2 version, we released the first beta version of our API group. It's called v1 beta 1. And now, since the previous version was an alpha version, which is v1 alpha 2, it is not required for that version to be part of the new release. And same as before, the release notes must be updated to notify users to migrate from v1 alpha 2 to v1 beta 1. Now that we are in beta, going forward, things are going to change, because rule 4a states that beta versions need to be supported for 9 months or 3 releases, whichever is longer. So continuing to X+3 release, now on X+3 we have v1 beta 2 released. Now, as we discussed earlier, from the beta version onwards, it is required to have the previous beta release, which is v1 beta 1 in this case, as part of this release. So this release has both the new beta version as well as the previous beta version as part of this release. The v1 beta 1 version is now deprecated. And note that v1 beta 1 version is only deprecated but not removed. So it's still part of this release. It's still going to be there for a couple of releases before it is actually removed. So if you were to use the v1 beta 1 API at this point, it would display a deprecation warning. Now also note that at this time, v1 beta 1 is continuing to be the preferred version. So why is that? Why isn't the v1 beta 2 version the preferred and storage version? Because rule 4b states that the preferred API version and the storage version for a given group may not advance until after a release has been made that supports both the new version and the previous version. So in this case, the current release is the first release where both new and previous version, that's beta 1 and beta 2, are supported. So we cannot change the preferred or storage version yet. Instead, we must wait till the next release. The next release also has both the versions, except beta 2 now becomes the preferred storage version. So continuing on, with version X+5, we now finally have the v1 GA stable version. But along with that, we also have v1 beta 1 and v1 beta 2 versions. v1 beta 2 is still the preferred or storage version because this is the first release that has the v1 version. But it now becomes deprecated. So now v1 beta 1 and v1 beta 2 are deprecated. In the next release, we can remove v1 beta 1 version because as per rule 4a, a beta version needs to be supported for 3 releases. Beta 1 version was deprecated in release X plus 3, and it's been around for X plus 4 and X plus 5, so that's 3 releases, and it can now be removed. With X plus 6, v1 can now be the preferred and storage version, while beta 2 is going to stay around for another release to complete its 3 release support. With X plus 7 version, nothing changes as beta 2 continues to stay around for the last time before it will be removed. And in X plus 8 version, beta 2 is removed and we are left with just the GA stable v1 version. That's kind of how a version progresses. Now, let's say, for example, with the next release, we are now for the first time having the first version of v2. So we decided to start working on a v2 version, and we now have the v2 alpha 1 version available for the first time. Now, if you look at the releases in the past, every time we had a new version available, we immediately deprecated the older version. So now that we have the v2 alpha 1 version ready, can we deprecate the v1 version now? No, because that's where rule 3 comes in, and rule 3 says an API version in a given track may not be deprecated until a new API version at least as stable is released, meaning GA versions can deprecate beta or alpha versions, but not the other way around. An alpha version can't deprecate a GA version. In this case, the v2 alpha 1 is an alpha version and v1 is a GA version. So we cannot deprecate v1 now. The v2 alpha 1 version needs to go through its life cycle of becoming a v2 alpha 2, then v2 beta 1, then v2 beta 2, and then v2, and only then can the v2 version deprecate the v1 version. So that brings us to the final topic of this video, the kubectl convert command. Now, as we have been seeing, when Kubernetes clusters are upgraded, we have new APIs being added and old ones being deprecated and removed. Now, when an old API is removed, it is important to note that you have to update your existing manifest files to the new version. For example, say I have a YAML file with a deployment definition of v1 beta 1, and when Kubernetes is upgraded, the beta 1 version of deployment is removed. So I would need to use the v1 version going forward. However, I may have a lot of YAML files in the old manifest, in the old version, which has v1 beta 1 in it. So to convert my YAML files to newer version, you may use the kubectl convert command and specify the old YAML file and the new output format. For example, to convert this deployment definition file to the new version, run the kubectl convert command and specify the old file name followed by the new version, which happens to be app/v1. And this will output the new version of the manifest definition in YAML format on screen. Note that the kubectl convert command may not be available on your system by default, and that's because it's a separate plugin. So the kubectl convert command is a special plugin that you have to install. The installation instructions can be found in the Kubernetes documentation pages, along with the instructions for installing the kubectl utility. And so it's available at this link.
Okay, so let's get some hands-on practice. So in our CKAD course, we have a lab for the APIs. So I'm just gonna open that up. And yeah, this one. Okay, let's start the lab and let's give it a few seconds to load. Okay, so the lab is now open. So let's go through it. So the first question is, so the lab is a combination of multiple choice questions, which basically get you to explore the environment and get some answers.
and there are also some configuration tasks that you have to do, which will come later on. So the first question is identify the short names of the deployments, replica sets, cron jobs, and custom resource definitions. So from the lecture, we have learned that we have a command called Cuddle API resources, which is actually going to list all the API resources and the associated short names, as well as the API version, and also if there are namespace or not, right? So here we want to find out the short names for deployments. So here's deployment, and the short name is deploy. For replica sets, it's RS, and for cron jobs, it is right here. So it's CJ, and custom resource definition is CRD, right? So we have deploy, RS, CJ, and CRD, and that's the correct answer. Okay, so for the next question, what is the patch version in the given Kubernetes API version? So the given version is 1.22.2. We know that this is the major version, and then we have the minor version, and we have the patch version. So in this case, the patch version is number 2. Okay, the next question is identify which API group a resource called job is part of. So here we have the different API. So here we have jobs, and we go here, you can see that it's part of the batch/v1 API group. So the correct answer is batch. Again, so all of these can be all of the answers to these questions can be identified from just this Cuddle API resources command. The next question is what is the preferred version for authorization.case.io? So we learned that from the lecture, we learned that you could use the Kubernetes API and search for the authorization API to get that. So let's try that. So we're going to look at first we need to access the Kubernetes API, and we know that with Cuddle you could run a proxy and access the API. So the API is available at 8001. Let's do a curl to localhost 8001/API. All right, so we know that it's working. The API, we're able to access the API. Now, what we could do to find the preferred version of any particular API is by going to the API called /apis/authorization.k8.io. And here you see the versions that are supported are v1 and v1 beta 1, and the preferred version is v1. So that's the correct answer here. Also, so the next question is enable the alpha version rback.authorization.ks.io/v1 alpha 1 by setting up the runtime config flag on the Kubernetes API server, right? So we learned that by modifying the Kube API server YAML file and by adding the runtime config, we can enable alpha versions, because alpha versions are by default not enabled. So let's see how we can get that done. So we're going to let's stop this API server. Okay. We know that the manifest file is in /etc/Kubernetes manifest, and here we can see the Kube API server. Okay, now what we need to do is add the runtime config here and pass in this particular API. So that's what we're going to do. Let's first see if there is already a runtime config. So we don't see a runtime config. So we are going to, and before you make a change, always take a backup. So I'm going to take a backup of the API server. I'll call it .bak. And now we're going to edit this file. Okay, and we'll add the runtime config to it, and this is going to be rback.authorization.k.io/v1 alpha1. Okay, and all we have to do, since this is kubedm based cluster, we just have to save it. And so let's see if at this point the API server is going to restart, so we just have to wait and give it some time for it to restart and for it to take effect. And in case you are in doubt, you could actually look up at the hints or solution to know what the answer, to know the steps that you have to follow. Okay, so I think that is back up. So let's test our task. Okay, so that's complete. Let's go to the next one. All right, so the next one is to install the Cuddle convert utility. So let's go to kubernetes.io and search the documentation pages for Cuddle convert. And the instructions to install the Cuddle convert is part of this page, which talks about installing and setting up Cuddle on Linux. And Cuddle convert is a plugin. It should be available towards the bottom. Right, so this is it. Let's copy this. So the checksum file. So let's see if the output is okay. That's correct. So the checksum has been verified. And next we're going to install Cuddle convert. Verify that operation is successful. Okay, so that's working. All right, let's check our task. It works here. I think the instruction is for it to work anywhere. Okay, still works. Okay, so I think we need to fix this, but I think this is because from what I see, the solution expects it to be available at user bin, but this is it's available at user local bin. Just to get through this for now until we fix our validation, I'm just going to move this to user bin. Okay, we've got to fix that. All right, next one is the ingress manifest file is already given under the root. So let's go to root, and here we have an old ingress file called ingress old, and it has the API version networking.case.io/v1 and what we need to do is, with the help of kubectl convert command, change the deprecated API version to networking.case.io/v1 and create the resource. So let's go and try that. Kubectl convert, and the file is old. So file is the old file, and the output version would be current file, and the output version, and that's going to be whatever is given here. Okay. Because I've moved the path. All right, and then I am going to we have to create. So here, as you can see, it's already converted the version to v1, and so I can just create the next step is to create the resource. I'm just going to create -f-. So I'm just going to pipe that output to the kubectl create command. Okay, that's done. Check the work. All right, that's done. Awesome. Well, so that's all for this demo. I hope you enjoyed it. If you like this video, don't forget to share and subscribe, and I'll see you next week with a new video.